Malik, can you wake that dude up there? Yeah, yeah. Just give him a slap around the head, okay? Alright, next now. Tangents and normals. So the good news is this lesson, unlike the last lesson, not so difficult. And some of the vocabulary you already know. You remember this word, of course? Tangent. So here is my curve, and then here is my tangent. Here is my tangent. Tangent. Does anybody know what normal means? Very good, yeah. The normal is the line which is perpendicular to the tangent. That's all. So that's not too bad. So just write those two words down and the picture as well to help you remember. So this one is the normal at x, and here is x, and this one is the tangent at x. Can you write that down, please? Got that? Yep. Okay. No, you don't?
No.
Yeah? Yeah? Okay. So I'll just go straight into an example. So for example, I have this curve here, y equals e2x. And I'm here at x equals 1. And I want the equation of the tangent here, and I want the equation of the normal as well. So first, I'll do the tangent. So the equation of a tangent line, or the equation of any line, is y equals mx plus c. Right? We know how to find the m. How do we find the m? Derivative. So, who remembers what the derivative of this is? What is it? 2e 2x. But the x we know, what's the x? It's 1. So this will be 2e squared. And if you want that as a decimal, that is 14.78. So this is the slope. Y equals m x plus c. How can I find the c? Use a point. What point do I use? Yeah, we know what the x is. The x is 1. How can we find the y? Well,
in the formula.
Yeah, we have the formula. So what would the y be? It would be e squared. And that is 7.39. 7.39. So let's put that in and we can find the c. 7.39 equals 14.78 plus c. So c equals 7.39 minus 14.78. minus 7, oh, it's the same, of course, 7.39. So you have y equals m x plus c. So that is the tangent line. Now we need to find the normal line. So just 1 minute, I'll let you copy this down, and then we'll do the normal. You taking a selfie?
No.
Oh, good.
I have a question.
Yes.
For the derivative, why is it 2x? Shouldn't it be
That's the
y?
formula I gave you. You have the table I gave you?
Yeah.
So in the table, we have EKX's derivative is KEKX. Yep. Okay. Can I do the next part with the normal? So, if we want the normal, we must find the tangent first, because for the normal, we don't know the slope. But if we know the slope of the tangent, we can know the slope of the normal because it's perpendicular. So yeah, what's the slope of, this is the first answer by the way, what's the slope of the normal? It'd be minus 1 over this one here, the last slope. So minus 1 over 14.78. Minus 0.0676. Okay, so 676 then. Yeah. So we have y equals m x plus c. How can I find the c? Like last time, I use a point. So I'll use the same point because it's, well, there's only one point. So I'll put this point now in here and I'll get 7.3, I can't see it anymore, 7.39 was it? Equals minus 0.0676 plus c. So c equals 7.39 plus 0.0676. So we'll 7.46 then. And now we have the normal. Y equals m x plus c. So this is the tangent and this is the normal. Okay, so write that one down. Got that? Yeah? Yes? Okay, I'll give you one to try. If I can go down? Yeah? Okay. We'll say something like, here is the curve y equals root x, and then here is the point, we'll make it nice for you, we'll make this 9. So what I want everybody to do for me is get the tangent line at the point 9. So here we go, that's the x and that's the y. Okay, try this please. That's a 9. nearly finished. You got an answer there? Yep. Yeah? No? Let's have a look. So, we have y equals mx plus c. Oh, I might as well write it in here now. If the x is 9, what's the y? 3. Square root 9. Okay, y, or fx, if you want, is x power a half. So what's the derivative here? A half x minus a half, which is 1 over 2 root x. But what's the x? 9. So it's 1 over 2 root 9, which is 1 over 6. Yes. Yes. So 1 over 6. So now we have y equals 1 over 6x plus c. So I'll take this point and put it in. 9 equals 1 over 6 times 3 plus c. Not. Oh, I have it backwards, don't I? 3 equals 1 over 6 times 9 plus c. 3 equals 3 over 2 plus c. So c equals 3 over 2. So I have y equals 1 over 6x plus 3 over 2. Right. This is the tangent, which is what I want for. I want you, if I make x 9 in this, if x is 9, what do I get for y? 3. Because the 9, 3 is on the tangent and it's on the curve. Okay. Now let me show you why tangent lines are useful. So let's imagine you don't have a calculator. I didn't use my calculator for this. Okay. And I want to know what is the square root of 10. Well, if you look at my graph, you can see that if I go to 10, here is the square root of 10, and that should be about the same as what happens if I put 10 into my tangent line. Now it won't be the same, it'll be a little bit bigger than the square root of 10, but it should be close. Let's see what happens. Whoa. So square root of 10 will be roughly 1 over 6 times 10 plus 3 over 2. So that's roughly 5 over 3 plus 3 over 2, which equals over 6, 10 over 6 plus 9 over 6, which equals 19 over 6, which is 3 plus 1 over 6, which is 3.167, isn't it? Something like this? Yes, let's see what the square root of 10 is. 3.162. Not so bad. So this is why tangent lines are useful. Before people had calculators. This is really good because, the true value is, let me check here. What did I say it was? The true value is root 10 equals 3.16227766. So this is really good. So you can imagine, okay, if I ask you for the square root of 27, you should make a tangent line where? At 25. You can make a tangent line at 25. Because you know what the square root of 25 is. What is it? 5. So, you can make a tangent line and then you can get an estimate. Now, that type of question, oh dear, this type of estimation is not on the exam. It was on the exam in the past, but it's not on it anymore. So you don't have to worry about this for the exam, but I still think it was a good idea to at least show you why a tangent line is useful. It's useful because you can do approximations for things like this. But for the exam, all they'll ask you to do is get the tangent line or the normal line. So just to finish this example, what I want everybody to do now is to get the normal at this point. Okay, so can everybody do the second half now, which is to get the normal? Okay, so I'll do it here in a minute, but give me the normal now. Normal. No need to think, just do. Got it already? Yes. Okay, let's have a look at it. So for the normal, what's the slope? If the last one was 1 over 6, then the slope here is minus 6. And we find the c by using a point. So I get 3 equals minus 6 times 9 plus c, yeah, so minus 54 plus c, so c equals 57. So here we go, y equals minus 6x plus 57. So what do you think, section A or section B? Section A, because, I mean, well, just to be clear, in the exam, they don't usually ask you to do both. So in the exam, they will ask you to do tangent or normal. So each of these could be a section A question. Now, which is more difficult to do? The normal is a little longer because you first need to get the slope here before you can do the normal. It's only a little longer than tangent. And please read the question carefully, because sometimes students confuse tangent and normal. So make sure you know which one they want. Okay. Alright, so let me tell you which ones to try here. One to 10. No, that's a little, you don't need to do all those. 1, 2, 3, 4. 8, 9, 10. So you can cancel 5, 6, 7. Yes? After everybody's tried it. So I can do it in the tutorial next week. Or, you know what, I can just do it at the start of the next class. But I want everybody to try it before they see it.
I did it, but I didn't do it on the phone.
Oh, well, I can come over and check what you did then. Yeah. Okay, try these now for a few minutes.